This conference will now be recorded.
Sir, audible, sir.
Yeah, audible. Okay. All right. So today is day 3. So before I start up the session, I would like to share the SPSS file so that you can access it. So I hope that everybody is having SPSS in your laptop. So what I will do is I will share the SPSS file that we have imported from Excel, and we did some variable changes. So that I'm going to share it in the WhatsApp so that you can use it for today's data analysis purpose. So just give me a moment. I will share it in the WhatsApp. Just give me a moment. Okay, so now I will share it in your WhatsApp group so that you can install it. So not you can use it. If at all already you have prepared, then absolutely not a problem. I'm actually sharing it. Just give me a moment. This is basically an SPSS file. It's not an Excel. So you will be able to open this file only in your okay. Some confusion is there. Is there any common mail ID is there, sir? Raja sir, is there any common group mail ID is there for this group? So that this is actually, I'm not able to.
Sir, no such group, sir. We have a WhatsApp group.
That's what I'm trying to share because it's in Android. It is trying to detect. All right. Okay. I think I'll be able to send it. Yes, I already sent it. Okay. So right. Did you receive the SPSS file? Okay.
Yes, sir, received.
Received it. Okay. So can you please open that SPSS file? Okay, I'll tell you the way how you have to open it. So right now I'm going to share my screen and I will walk you through the steps. Okay, where is the screen sharing option is there? Oh, here it is. All right.
So that format is not supporting, sir. I'm sorry.
No, it will not support in your Android, ma'am. But if you download it in your laptop and when you will not be able to see that. But I'll tell you the way how you have to open. Just download it in your normal folder. Maybe most of us will be downloading it in the download folder. After that, you open SPSS. Okay, I'll do one thing. I will close this. Okay, I'll close everything. So now, ma'am, have you downloaded it in your laptop first? Have you downloaded the one which I have shared in your laptop? The format
Sir, actually, I downloaded in mobile. I will just check it.
Mobile will not support because it should be in Windows, and that Windows laptop should have SPSS installed in it. Windows or Mac, whatever it is. It will not support in. So now, if you have downloaded the SPSS file in your laptop or in your desktop, how you have to open it? Just in your browser, bottom left. This is the normal way how you have to open SPSS software. Just search SPSS. Okay, you will be able to find some options. Option like open is there. Click on open. Once you clicked on open, it will take some time, almost a minute. depending upon the configuration of your laptop. Now it is opening. So right now what I'm having is SPSS version 20 with me. Probably you may be having the latest one. Click on cancel button. Now this is the blank window of SPSS. Now through this window at the top, you will be able to find an option called file. And normally this is the option which we use it for opening any Excel file also. Same way, click on open and go for the first option, data. Click on data. Now file of types, you have several options out there. You can choose Excel, .csv, SAS. All right. So now because the one which I have shared is in SPSS format, that is in .sav format, you have to choose this option and then look for the path where you have downloaded. Most of us will be downloading it in the download folder. I have downloaded in a particular path which is in my F drive, which I'm going to retrieve it from the F drive. So now I'll go to my path, F drive, training and workshop. So now I have organized like this. So in case if you have organized, then you need not to worry about it. So this was the file that I have shared a while ago, that is SPSS training survey.sav. Click on open. Now once you click on open, you are done. So automatically you will get this file. Now I would like to know, out of these 12 participants, whoever has logged in, is everybody is on the same page. You need not to do anything. You just have to download the SPSS file that I have shared and open the SPSS file using SPSS software in your laptop or in your desktop. Are we all in the same page so that we can go next?
So please, can you repeat once again the steps?
Okay, ma'am, have you downloaded the SPSS in your laptop
Yes,
first?
sir. Yes,
Or in
sir.
your
Yes,
desktop?
sir. Yes.
Okay.
Yes.
So have you installed SPSS? Have you installed SPSS in your laptop, ma'am? Like we did some
Yes,
steps.
sir. Yes. Yes, sir.
So can you open SPSS? Just
Yes.
normally like
Yes.
bottom, SPSS is open. Like how, click on at the top left, you will find an option like file.
Yes.
Top left, file and open.
Yes. Okay.
And then choose the first option, data.
Okay.
Choose that option and look for the path where you have saved the SPSS file.
Okay.
Maybe you would have downloaded it in download folder or C drive, D drive. And more importantly, choose this one. By default, it will be in format, which is the format that I have shared. You do also have another formats like .csv, Excel. Right now, by default, it will be in SPSS format. So no need to change the file of types. Choose this one and choose the file whichever you wanted to choose. And click on open. You will get this window. Done?
Thank you. Yes, sir.
Right. Anybody is having any other confusion? Because see, this might sound very silly. Of course, if you're already aware of SPSS, then not a problem. But somebody who is learning SPSS for the first time, who wanted to use SPSS as the data analysis for their research, this is extremely important. Because first, my data should be ready for SPSS. Now, before I go on the further steps, I will repeat whatever I have told you yesterday. These rows, okay, from 1 to 23, it represents the respondents. And the columns, like age, height in centimeter, weight, it represents the questions. If I have asked some 10 questions, I will be having 10 columns. Okay. If there are some 23 respondents in our case, I think 23, yes. So all these 23 will be filled. So now don't change this format. Don't keep questions on row and respondents on column. So let this be the format so that let us not have any confusion on this. And this you can see that in something called data view. In variable view, we will be defining the cells. So we are actually explaining the characteristics of the question. Say, for example, I have mentioned the age should be in numeric form. Height should be numeric form. Gender in string. Marital status, it is in string. Okay. So income, though though it sounds as though it is in numeric, the way that I have collected is in the form of categorical in nature. And I have also mentioned the respective level of measurement. And there are basically only 3 levels of measurement, which is nominal, ordinal, and scale. If it is a categorical in nature, use the term nominal. If it is in the form of rank or interval, use ordinal. And if it is you are collecting as a raw data like age, height, and weight, where you can use all kind of arithmetic operations like mean, median, mode, use scale. So accordingly, I have chosen these levels of measurement option. This also you can find it. You no need to change anything. Apart from this, this is one option where we had a small confusion yesterday, where you can rename this string into numbers for ease of calculation. You need not do also, that's up to you. But for ease of calculation, I have renamed it as. So by default, gender, male and female, 2 options are there. I would like to give the code 1 for male and 2 for females. So that means I can give value as 1 and label as male. So instead of be getting it as male, we will be getting as number 1 in SPSS. Similarly, when it comes to marital status also, I have given 1 for yes and 2 for no, right? Meanwhile, when it comes to income class, I have 3 type of income class: lower middle class, and upper middle class. For lower middle class, I have given the code as 1. Middle class, I have given the code as 2. And upper middle class, I have given the code as 3. And I have clicked on OK. Now, once I have fixed this, naturally, I can check out, I can toggle this window. Here at the top, you are able to find this value labels is there, like 1A. If you choose this, you will be able to see, oh, okay, 1 minute. Okay, now here, here, instead of you having it as here, I want you to do a small correction, because that's the reason why we were facing a small difficulty yesterday, which I do not want to have today. So if you can do along with me so that we will not have any confusion. Now what you have to do is, 1 minute, you have to change, okay, you have to change, I have mentioned it as 1 for male and 2 for female. You just have to do male as 1, male, okay, male as 1, you can label it as 1, okay, and for female, and you can remove this, and for female you can mention female and you can label it as 2. Okay, so basically because I have collected in the form of string, I'm doing this, and you can remove 2 for female. So what I have done is that instead of I mentioning it as 1 for male and 2 for female, I'm mentioning it as male is equal to 1 like this and female is equal to 2. That's the reason why I'm not able to. Okay, look at this, here you can see that now you are able to find this gender, male and female. You can do this or you choose not to do this also, it is up to you. And similarly, do the same one for here also. Here also, you can use yes for 1, okay, and no for 2. And you can remove these options because by mistake I have coded in reverse. Okay, here you can see these options. Probably here this small missing value is there, which is being taken care of. You can see both gender and marital status I'm able to change. I can do this even for income class also, because now income class it is not changing. So similarly for income class, instead of I mentioning 1 for lower middle class, mention it as lower middle class is equal to 1 like this. lower middle class is equal to 1. Right? Similarly, for middle class, 2 is equal to middle class. You mention it as middle class is equal to 2. And similarly, when it comes to upper middle class, instead of you mentioning it as 3 for upper middle class, mentioning it as upper middle class is equal to 3. And delete the previous options. Oh my god. Middle class is equal to 3. Okay. So now you delete these options. Remove it. Remove it. Remove it. Click on OK. Now if you go to the data view, okay, some confusion is there still. Lower middle class, upper middle class. What is the confusion here? You can see that lower, maybe is it case sensitive? I'll check out. Okay, now you can see that the one which I have coded, it is actually case sensitive. So here I'm changing it accordingly. So change it. Okay, so these are all small errors that may prone to occur in case if you are not coding it properly. So you should know how to rectify it also. Otherwise, okay, now here, okay, now look at middle class. I have given caps. So this is very case sensitive. So I'll change the middle class into caps here. You can do or you need not to do. That's not a very much important, but I prefer to keep it in the form of quotes because I can do certain data analysis based on that. You choose not to do that also. That doesn't make any difference for our today's session. So have you done that? Any confusion on this? Anybody is having any confusion on this? Have you did this reverse coding?
Yes, sir, done.
Right. So this is the small error that I have made. Then I was able to find out. If you're not done also, it is okay. You can just like that leave it. But I prefer to keep in the form of codes instead of me having, even for example, COVID vaccine, yes or no. You can go for this COVID vaccine. I can give the code as yes for 1, okay, and no. I can give it as 2 and click on OK. Now you can see that. So everything. So now I have. Now what is the advantage? I have everything in terms of numbers, so that it becomes easy for SPSS to do all kind of arithmetic operations. So there is no string variable which is involved in it, right? Okay. Now with this understanding, now we are actually going to get into the main part of the data analysis. Now look at it. How much time that we are spending for preparing our data. So the data analysis is just the click of the button, click, 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 you'll get the output. That is why many of the researchers, they call SPSS as GIGO. That means garbage in and garbage out. But what does really matter is, there is certain thing which has to be done before using SPSS and after using SPSS. The one which you should do before using SPSS is, you should clean the data, prepare the data, ensure that there is no error in your data. After you have got the output, you as a researcher, we should know how to interpret the data so that we can make some sense out of it. So these two things, pre and post, is extremely important compared to we getting the output. Output, you can see the output, okay? If I start using correlation, regression, or whatever technique, no, it's very easy, okay? What is more important is that before and after is very much important, right? Now, yesterday I was telling you about reliability. Are you clear with it, or you want me to repeat it? Because end of the session there was some network issue was there, so because of this I need to rush it. You want me to repeat that, what is meant by reliability and validity, and then continue with today's session? Yes, no? You want me to repeat the concept of reliability and how do we have to do reliability using SPSS?
Yes, sir, you can move forward.
Yes, fine. So okay, now there are when you are presenting your thesis, okay, of course you will be doing a lot of statistical tests, okay, and at times some of the statistical tests what you are presenting, the panel may not be aware of it. You may be using AMOS or you may be using factor analysis, cluster analysis, but there is basically I have come across researchers, they are not aware of two important things. The first question what the panel will ask, or if your guide they will ask is that, is your questionnaire reliable and valid? What question they will ask? Did you do the validity and reliability check? Now we as a researcher, we have to confirm, we have to understand what is meant by reliability and what is meant by validity. Like I have told you yesterday, reliability, if I'll share you that PPT so that you can take a screenshot of it, okay. So what is meant by reliability first? So reliability is nothing but repeatability, okay. Repeatability, reliability is nothing but repeatability. So that means whenever I'm measuring something, I should be able to get the same result. Say for example, I'm taking a session for you. So yesterday's session was good, today's session is not good, tomorrow's session is not at all good. That indicate that the reliability, the consistency is not there. So what do you mean by the term reliability is that if a respondent is giving a positive response today, he should also give negative response tomorrow, day after tomorrow. So that is what we call it as reliability. And I have told you with an example of a weighing machine. If I'm checking the weighing machine and it is showing it as 68 kg, okay, tomorrow also it is showing approximately 68 kg, another day is also 67.9 kg, I can say that it is reliable. What is validity? Validity is the accuracy of the result. What do you mean by the term accuracy? The questionnaire that you are having or the tool that you are measuring, is it actually measuring what you want to measure? Say for example, you have designed a questionnaire to measure trust, and you are asking the question, in general, do you believe one other person? Through this question, you are measuring whether the person is having the trust. Is it trust or trustworthiness, or is it commitment to something which talks about validity? So that means when you talk about some of the questions, the question should measure what you want to measure. See, there are certain abstract concepts like trust, communication, commitment, honesty. These type of questions are very, very abstract. So when you are designing questionnaire for these type of questions, you need to get an opinion from an expert that is this the question that I need to ask so that I can measure that particular construct. That is what we call it as validity. And more precisely, I have told you the concept of content validity. Content validity, you can mention, you can say that the questionnaire has been tested for content validity by discussing with the subject matter expert. That's it. Nobody will ask further question about it. When it comes to reliability, as I have told you, of course, validity talks about the accuracy. When you wanted to measure, or you measuring what you want to measure. Reliability talks about repeatability. How do we test it? One way of me doing it is test, retest reliability. That means today a person has taken the test. Tomorrow when he is giving the test, he has to give the same result. But in reality, once we have collected the data, say from 500 participants, it becomes extremely difficult to get back the same participants. So what do we do is that within the question itself, we will ask similar questions so that to check out whether the respondent is giving a similar answer, so that we can confirm that yes, his answers are reliable. Say for example, you wanted to measure somebody is an extrovert or an introvert. Extrovert, you are asking two questions. Are you a talkative person? For that, he is telling yes. Second question you are asking, are you a silent person? For that also he is telling yes. Now tell me, will you accept this response? Or is there a problem in this response? How do you categorize this person? Do you categorize this person as extrovert or an introvert? Because first question you have asked, are you a talkative person? For that he is telling yes. Second question you are asking, are you a silent person? For that also he is telling yes. is this answer, is his or her answer is reliable? Is his or her answer is reliable? Absolutely no. How do we? Because see, our objective is that to categorize somebody as an extrovert or an introvert. But he is giving a contradictory answer. See, I'm asking a question, did you eat apple? For that he's telling yes. Was the apple eaten by you? For that he's telling no. I can't consider this answer because it is not reliable. It doesn't matter whether he eat an apple or he don't eat an apple. That is a different argument altogether. Here what is matter is that are we getting consistency? For that reason, whenever we are measuring any construct is a qualitative variable which is abstract in nature, not like income, gender, or it is an abstract. Say for example, satisfaction, honesty, these are all construct. These questions has to be measured, these construct variables has to be measured with several questions. What do you mean by these several questions? See, whenever we talk about somebody who's an let's say for example CAT examination. Now there is a stringent process which IIM follows. They wanted to recruit, or they wanted to take only the brilliant students. Now according to IIM, what is the parameter that they are keeping for brilliance? What are all the parameters that they take? Of course, CAT examination, interview, and group discussion. Within CAT examination, they need to clear the aptitude, language, analytical ability. So of course, there are basically 3 important parameters. Based on that, they are judging the intelligence of a person. That is what we call it as. Okay, we wanted to check, is there any consistency in that result? Fine. So I will get into the concept of reliability and check how do we check these reliability scores out there. So for that, I'm actually going to the data. And I hope that you all are having SPSS, right? Now, before I use this reliability, there is one question which is negatively framed, which I have asked in the negative context, and that is related with life satisfaction. Look at this question: life satisfaction is ideal. Can somebody say in the question, that is the last 5 questions, I mean this one, the last 5 questions, which question is negative in nature? Which question is negative in nature? Negative. I have asked questions which is related with, is life ideal? He has to rate it from 1 to 7. This question is, are you satisfied? Important things, life overall. But the second statement is something which is related with not excellent. I haven't asked that the conditions of my life are excellent. I have asked the statement, the conditions of my life are not excellent. Now here I have purposefully negatively correlated. That is, I have reversed. That means a person who is satisfied with his life. Now look at the response, especially somebody who has given 4, he has given 6. Somebody who has given 4, he has given 1. Okay, why I have asked is that I wanted to check whether the respondent is properly reading the statement and they are giving the answer. So that way I will be able to make out whether the person is reliable or not. Now, before I do analysis, this actually has to be reverse coded because the statement is negative. Okay, obviously the answer what the respondent is giving, it will also be negative, that will be ulta. So what we have to do is that we need to reverse code it. That means we need to convert this not excellent statement to an excellent statement. So for that, we have to go for some option called transform. Go to transform. Okay, go to transform. All right, and there is an option called recode into same variables. There's an option called recode into same variables. Click that option. Scroll down. Towards the left hand side, you will be able to see all the options which is related with life satisfaction, and more particular about the negative statement where life satisfaction underscore not excellent option is there. Okay, that statement. Now choose that and bring it towards the right hand side, which is actually a negative statement. I wanted to reverse code it. Click this option of old and new values. Now give the code as 1 and the new value should mention it as 7. Add it. 2 and the new value should be 6. This is how I'm reverse coding it. Okay, I hope you understand the logic behind this. Ma'am, are you able to follow this? How to get into this recode into same variable?
Yes, sir.
Yes, right. 3, you can go for 5. I hope you understand the logic behind it, because the statement is negative, the coding also should be negative. So that means I'm converting the negative statement into a positive statement. All right. So 4, it should be 4. Okay. I'm increasing the value on one side and decreasing the value on the other side. 5, it should be 3. And 6, it should be 6. It should be 2. And 7, it should be 1. Look at it. I've mentioned all the old values in ascending order, new values in descending order. I hope you understand the logic behind, because I'm trying to convert the negative statement to a positive statement, and I will do the correction also. Click on continue, click on OK. Now, what has happened is I have converted the codes into a reverse one. Okay, so earlier, okay, now, but the statement reads it as negative. That also has to be changed. So what I have to do is go to this variable view and choose this not excellent and convert it into excellent. Okay, that's it. Now my data is perfectly ready for any kind of analysis. Okay, including reliability and validity. Sir, where is the window found to recode? Okay, now I told you that once again I'll repeat the path. Go to transform and you will be having an option called recode into same variables. You can choose to recode into a different variable, but I prefer to have in the same variable, and I have chosen this and then click on okay like this. Now please, if you are very sincere, if you really wanted to learn, take a diary and make a note of this path. Don't depend on the recorded video, because the recorded video is 1.5 hours. You don't know which concept that you need a refreshment. Something like path and all, it should be written in a diary or maybe in your notepad so that you can quickly refresh it. Okay, right. So once you have done this, now I'm going to get into the reliability part. So I'm going to do the reliability test one more time after I have recoded it. And reliability, I have told you that I'm going to use it for the construct only. No need to test reliability for a variable which is not a construct. For that, you have to understand what is meant by construct. What is meant by construct? Construct is a abstract variable which can be captured with so many questions, not 21 questions. You wanted to ask are you a human being? If I say yes, of course I'm a human being. You don't need to ask again and again. Okay, but if you're asking me, are you a honest person? This you cannot ask with only one question. You need to ask with several questions, and those several questions are interrelated with each other. So my answer also should be similar. This is what we are talking about reliability. How do I test it? Click on analyze. Okay, click on analyze and scale. Analyze, scale. There's an option called reliability analysis. Ma'am, are you able to find it? Sir, ma'am, whoever it is. Are you able to find it? Yes. Okay. Right. So
Yes, sir.
choose that reliability analysis. And I'm actually interested in checking the reliability only for the construct called life satisfaction, and to check out whether the statements are interrelated with each other. Choose all these options. So press this control button and choose whatever you wanted to choose. ideal, life satisfaction ideal, life satisfaction excellent, life satisfaction satisfied, important things life over, and bring all those variables, whatever that I have selected, towards the right hand side. The moment you are bringing it towards the right hand side, that means I'm going to analyze only these variables, not the other one. Look at these variables are not construct. Age is not a construct. Height is not a construct, because I'm not asking too many questions. Okay. Choose statistics, and you choose only this option: scale if item deleted. Scale if item deleted, and preferably you can choose this also. So these two options you can choose it. All right. Then click on continue. Maybe you can choose mean if at all, if it is required. Maybe correlation also you can choose it, but this is very much important. Scale if item deleted. It does make some sense. I'll tell you what exactly. Click on OK. Right. Now, as soon as you have got this result, have you all got this output? Have you all got this output?
Yes, sir.
Right. Have you all got this output? Yes. Yes. This output, you just have to look at the first table. You have a look at it. Look at this one, the Cronbach alpha. Okay, Cronbach alpha is 0.642. Okay, 642. If you are getting this output, if your output is above 0.6 to 0.8, it is moderately reliable. That means it is acceptable. You can say that yes, but you should not be too happy if your Cronbach alpha is just above 0.6. That means it is acceptable score. Something you can't reject it. Okay with that. So 0.6 to 0.8, it is moderately reliable. 0.8 and above, it is highly reliable. So here, acceptable score is there. The number of statements that I have chosen is 5. If you bring it down, we have chosen an option called items. Okay. Here, we have chosen an option called total item total statistics. Here, what does it indicate? That Cronbach alphas if item deleted. That means it shows if I delete life satisfaction ideal, that means if I don't consider, my Cronbach alpha will come down, which is not a good sign. That means it is 0.481. If I delete this life satisfaction excellent option, my Cronbach alpha will increase from moderately reliable, it will become highly reliable. That means 0.816. So what is the understanding what I have got is that if at all I wanted to reduce the number of statements, so that I wanted to improve the reliability score of my questionnaire, you have to delete excellent. I'm going to test it, but I'm not going to delete it. Why? Because according to me, this question is also very much important, which is also an important indicator. But nevertheless, I'm going to rerun this this reliability test by not considering the excellent. So for that, once again, I'm choosing analyze. So please work along with me. I must, okay, now again, scale, reliability analysis. Now, what did SPSS say? Please don't use excellent. If you are not using excellent, your reliability score will go up. So I'm not going to use excellent. Click on OK. Right. Now, what is the Cronbach alpha value? It is 0.816. Is it clear? Now, what is the takeaway of this? The takeaway is that it is better not to use the second statement for your analysis if you are very particular about improving your reliability score. Ma'am, have you done along with me? Are you able to get 0.816? Anybody is having any doubt?
Sir. Yes, sir, we got it.
Clear? Got it. Good. Right. Now we have done the reliability. In your research paper, in research papers, have you ever come across this convergent validity, discriminant validity. Have you ever come across these type of terms? Of course, I have told you about what is the meaning of the term content validity. That means you are discussing with an expert and your expert is telling, yes, okay, it is fine, that is content validity, or you have justified it with a literature review. Have you ever come across terms like convergent validity and discriminant validity anywhere in reading research papers or anywhere in your thesis? Have you ever come across anybody? No? All right. So I'm going to do a little bit complicated steps where, please, I want you to pay attention because that is the value addition of this training program, where I will be using, because normally this type of output you will get when we are using some advanced softwares like Amos. Now I'm going to test validity. Okay, I've told you about content validity, where you need not to do any kind of analysis. You just have to mention that I have discussed with the subject matter expert and they have told, yes, this statement is capturing which you wanted to measure. Now, apart from this, I wanted to look at this screen. Okay, I wanted to look at the screen. Okay, look at the screen, which talks about, okay, which talks about the concept of validity. Especially, I'm going to explain the concept of construct validity. Then I'm going to take you to the SPSS so that I can prove the construct validity. Now, first, you have to understand what is the meaning of the term construct. And I have told you that construct is nothing but the abstract variable, abstract idea, a qualitative variable which needs to be measured with question, not with only one question. Examples of construct is satisfaction, honesty, trust, communication, commitment. Variables like age, height, weight, these are all not construct because you don't use multiple questions. And this is not a qualitative variable, this is a quantitative variable. Right. So when we talk about this construct has to be measured with several variables. Say, for example, job satisfaction. When a person will be satisfied with the job, it is based on several components. First is that salary, recognition, growth, job surety, okay, and several other parameters. So at least you need to have 4 or 5 parameters. Based on that only, you are actually coming to a conclusion that yes, a person is satisfied with the job, and this is what we call it as construct validity. So what do you mean by this? The structured definition says that construct validity means the test that is designed to measure a particular structure is actually measuring that construct. Okay, now this construct validity can be classified into 2 things. One is that convergent validity and discriminant validity. What does this convergent validity means? I have told you that whenever you are measuring the construct, you don't measure with only one question, but you measure with several questions. Several questions means what? Which we call it as an indicators. Okay, and I have told you an example of convergent construct also. Say, for example, you wanted to measure somebody is an introvert or an extrovert, and for extrovert, okay, you are asking some 4 or 5 questions. How comfortable that you are talking to a stranger? Are you a talkative person? Are you a silent person? So 3 or 4 questions that I am asking. So ideally, if somebody is an extrovert, he will say, I'm comfortable talking to a stranger. I'm a talkative person. I'm not a silent person. This is an indicator of somebody who is a extrovert. Okay, because it is converging. The items are interrelated with each other. That is what we call it as convergent validity. What is discriminant validity? Discriminant validity means, let's say that you wanted to measure somebody is an introvert or not, and same question you are asking, okay, or let us say that you are actually measuring the trust, okay, and you are asking a question, generally do you trust other people? How comfortable that you are sharing the secret with the other person? Like this you are asking. And the questions which you have captured to measure the trust and the questions that you have captured to measure somebody is an extrovert or an introvert, they should be different. They should be different. That means it should differ. In convergent validity, the items, okay, the questions should be related with each other. In discriminant validity, because it is two different construct, it should not be related with each other, right? So now this is the basic difference between discriminant validity and convergent validity. Now, anybody is having any doubt on this? Because I don't know whether to what extent that you are able to understand this convergent validity and discriminant validity. Anybody is having any doubt? Because we are going to, you can be very frank, because it's not a very because your confirmation I can go ahead next, either in the chat or if you're telling. Are you able to find the difference between convergent validity and discriminant? See, for example, you are having two constructs. One way you wanted to capture somebody is an extrovert or an introvert. Another construct is that you wanted to measure the trust. The questions, the response for the response for the questions which is related with trust should be different from the response for the questions which is related with somebody is an introvert or an extrovert. So that difference is what we call it as discriminant validity. What is convergent validity? The questions which is related with the trust, the response should be closely related with each other. Similarly, the questions that I am capturing to measure trust or trustworthiness, the response should be related with each other within that construct. This is what we call it as convergent validity. That means it is converging. Discriminant validity talks about how they are not related with each other. Is it clear, man? Clear, sir? Anybody is having any doubt? Any more clarification which is required? Yes, no? Are you all with me? Okay. So can we go ahead with? All right. Okay. Anybody else? Okay. No doubt. Okay. Fine. So what I will do is, okay. What I will do is, I will prove this concept of convergent and discriminant validity using SPSS. Now for that, I'm going to choose the construct life satisfaction. I'm going to choose the construct life satisfaction, and I'm going to use factor analysis. Now I'm not going to explain factor analysis because there is a separate topic called factor analysis that I will be explaining it on almost on the 5th day or on the 6th day. But right now I'm going to use this exploratory factor analysis where I'm going to divide the life satisfaction construct into two types. Okay, and I'm going to check whether it is following the convergent validity and discriminant validity. For that, go to analyze, click on dimension reduction. There's an option called dimension reduction. Click on factor. As I have said, that I'm going to choose the construct of life satisfaction alone, and I'm going to divide it into two. Okay, because basically factor analysis is a data reduction technique. Meanwhile, somebody has. All right. Okay. So meanwhile, you can interact in case if you are having any difficulty. Okay. Once you have done that, go to descriptive. Need not to do anything. You can choose this KMO and Bartlett's test of veracity. Okay. Go to descriptive. Choose this KMO test. Then go to extract. Okay. Here, need not to do anything. You can leave it. Not a problem. Go to rotation. In rotation, choose Promax. In rotation, choose Promax. Click on continue. In scores, need not to do anything. Leave it. In options, choose suppress small coefficient. Okay, I will give you the separate explanation for it when we are entering into the chapter called factor analysis. Here we are using SPSS to determine whether our data fulfills the assumption of convergent and discriminant validity. For that purpose, I'm using it. Normally, if you're using some advanced softwares like Amos, the output window gives it automatically. Here, because we don't have that option, we are going for this lengthier step. So once you have chosen this, okay, click on OK. Right. Now here, the KMO measures of sampling adequacy. This is the acceptable range, which is above 0.5, it is okay. And this Bartler's test of veracity, it is significant, so that I can go ahead with this. Now, if you come down, you can see that totally there are two variables that it has extracted. That you can find it in pattern matrix. Now, what does it signify? It signifies that this pattern matrix, look at this pattern matrix, it shows that those 5 statements has been broadly classified into 2. First statement and the second one. That means I'm actually dividing the life satisfaction construct into 2 subconstructs. One is those statements where life ideal, life satisfied, life important things, and life over. These 4, so this one, these 3 statements, that is life ideal, life satisfaction, life important things. This is construct 1. And then life excellent and life over is construct 2. So these 2 constructs I'm actually choosing. So that means I have divided the life satisfaction into 2 constructs, and I'm checking these 2 constructs follow the pattern of convergent validity and discriminant validity. And I'm also interested in, okay, wait. Okay, here, yeah. I'm also interested in checking out the correlation matrix. So I will choose those tables which I wanted to analyze, that is the pattern matrix, okay, the pattern matrix as well as the correlation matrix, and I'm going to use it in Spss Excel. So right now I'm opening Excel and I'm going to paste these 2 tables and I'm going to analyze these 2 tables in SPSS, and I'm going to confirm whether they are actually following this convergent validity and discriminant validity. Now, the condition for convergent validity and discriminant validity that I have already mentioned it in the PPT. You can see that the average factor loading for convergent validity should be above 0.7, and the average variance extracted should be greater than the correlation. If at all you wanted to confirm that it follows this discriminant validity. Right now, I have these 2 outputs, which I'm going to paste it in the Excel. One is that pattern matrix, and the other one is component correlation matrix. Okay, right. Now, are you able to follow me? Do you want me to repeat the steps, whatever that I have told? Anybody is having any confusion till here? Yes. Yeah, Priya ma'am, what is the confusion that you have? You want me to repeat the path? Can you repeat? Okay. I'm going to repeat the path alone. Okay. I'm not going to explain. When convergent and discriminant validity, I have told that when you are actually finding out how the items are related with each other, that is convergent validity. Discriminant validity is opposite. How one item is not related with the another item. This is discriminant validity. With this understanding, I have chosen the construct life satisfaction, and I am dividing the life satisfaction construct into 2 subgroups, like component 1 and component 2, and I'm going to check whether the component 1 follows convergent validity within itself and component 2 follows convergent validity within itself. And I'm also going to check out whether is there any significant difference between component 1 and component 2. That is what we call it as discriminant validity. How do we have to do that? Again, go to SPSS, analyze. Okay, please listen to the path one more time we'll be sharing this recorded version of the video. Analyze, dimension reduction. I'm going to do a factor analysis. Bring all the variables which is related with life satisfaction towards the right hand side. In descriptive, choose KMO and BART plus test of veracity. Continue. Extraction. All right. No need to do anything. Just like that, leave it. Rotation. Choose this one. By default, maybe none or Varimax may be there, but choose this Promax. In scores, no need to do anything. In options, choose suppress the value which is lesser than 0.4. That means I'm actually considering only those values which are highly significant. So once you do that, automatically you will get this output. From these output, you please copy the pattern matrix and scroll down. Last option, you'll be able to find component correlation matrix and you paste it in Excel. Priya ma'am, is it clear? Priya ma'am?
Yes, sir.
Clear?
Yes, sir. Thank you.
Yeah.
Thank you, sir.
Right. So now, of course, I can't be very slow also because we have a lot of other topics to cover. I can't because it's just 1 hour. Okay, you really need to catch up along with my speed, right? And you'll be getting the recorded lecture also. That should not be a problem. Now, what did I say in the PPT? It is mentioned average factor loading should be greater than 0.7. What is the average factor loading? So that means factor loading, okay, that is average factor loading of component 1. Okay, average factor loading of component 1. Here, average factor loading of component 2. Now what I have to do is very simple. Very simple. You just have to average AVE or AG. Average of this. That's it. Which is coming 0.773. And I also need to find out the average of this component 2. Here there is only one correction that you need to do, is that it should be positive. If it is negative, please ignore. It should be in positive. So I am removing this negative sign. Okay. Right. Similarly, mention AV or AGE average. Choose this cell. Right. So what is the value that I'm getting? For component 1, the average factor loading is 0.7, and for component 2, sorry, not 12, it is 2, the average factor loading is 0.78. What is the condition for convergent validity in the PPT? The condition for convergent validity is, what is the condition for convergent validity? The average factor loading should be greater than 0.7. Is it confirming? Is it confirming? Is the average factor loading is above 0.7? Of course, yes. Yes, it is confirming. No doubt at all. Even if you take average also, what it is? Even if you take average of the above 2, average of component 1 and 2, then also it is. Right? All right. So, okay, fine. Then there is something called variance. Variance is nothing but the square of the average. Okay, this is variance. Okay, I'm actually squaring this. You can see that the condition for discriminant validity is AVE should be greater than correlation. This is the condition for discriminant validity. Condition for discriminant validity. Now here, this is the square of the average factor loading. Now what is the average? What is this AVE, average variance extracted? Is nothing but it is the average of this equal to average of this plus this divided by 2. So this is, that is the variance. Okay, this is the variance. Variance is what? Square of the average factor loading. Okay, average variance extracted is, this is the average of this. So basically I'm getting the value as 0.6. Okay, and it says that the AVE should be greater than correlation. What is the correlation here? What is the correlation here? It is minus 0.202. Okay, you can ignore the point sign, my signature. However, you can take it as 0.2. So that means it is greater than 0.2. So which confirms that discriminant validity is proved. Look at these two score. Okay, 0.2 is the correlation. Okay, AV is 0.6. Okay, 0.6 is greater than 0.2. We can say that this AV is greater than correlation. So which confirms the condition for discriminant validity. So through this step, what we have done is that we found out the average factor loading, okay, which is the average of this and average of this, which is about 0.7, confirming that there is a convergent validity. Discriminant validity, the condition is average variance extracted, which is nothing but the square of the factor loading, which I have done it here, and I have found the average also. And that average, AVE, average variance extracted, should be above correlation. Correlation value is minus 0.2, keep it as 0.2, so that we can say this is also confirming. So it is confirming both convergent validity and discriminant validity also. And we have also confirmed the reliability test as well. Is it clear? Can we go on to the next one? Is it clear? Ma'am? Yes? Okay. Right. So now my data is ready. So now you can report the finding in your thesis or your research paper that yes, my data is clear, reliability and validity test done. Right? You can write at least 2 or 3 pages. Now we are doing the first step today. Okay. Now we are doing the first basic technique called correlation. Now, first of all, we need to understand what is the meaning of the term correlation. That I'm going to explain correlation, and we are going to demonstrate using Spss. Now, what is meant by correlation? Correlation is how two variables are moving together, or is it moving in opposite direction? It may move in one direction, or it may move in opposite direction. If it is moving in one direction, we call it as positive correlation. If it is moving in opposite direction, we call it as a negative correlation. Let's say that if two stars are moving in one direction, we call it as positive correlation. If there are two stars which are moving opposite to each other, we call it as negative correlation. Let's say that if there are two students who are coming to class regularly, who are sitting next to each other, positive correlation. If they are bunking the class, they're bunking together, positive correlation. We found out if somebody is coming to the class, the other person is not coming, negative correlation, right? Zero correlation means where the two variables are not related with each other. There is no relationship between these two variables. That is what we call it as zero correlation, right? You can have several examples, okay, for positive correlation, for negative correlation, for zero correlation, right? So now, when you talk about correlation, basically, I have told you what do you mean by this parametric test and non-parametric test. What is the meaning of the term parametric test? When the variables are normally distributed, especially the dependent variable, we will be using parametric test. If the dependent variable is not normally distributed, of course, the dependent variable has to be continuous in nature. If it is categorical in nature, it can't be normally distributed. Then we will be using non-parametric test. When it comes to correlation also, there are two types of correlation. One is the Pearson correlation, which is the parametric type of correlation, which is very powerful. First, if at all, if you are planning to use correlation, first try checking out whether your data is normal and it is continuous. Okay, there are certain assumptions out there which I have mentioned it on the PPT. If it is fine, then go ahead with the Pearson correlation. If your data is not fulfilling the assumptions of a parametric test, then go ahead and try doing the equivalent non-parametric test, which is the Spearman rank correlation. Not only in correlation, even for other technique also, you have different type of correlation test. Now I'm going to test each and every assumption. Now we have the data with us. We have the data with us. All right. So now from now on, it's going to be very simple. Now it's not going to be pretty complicated like validity. It is just that I have told you, click, 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 you will get the output. Only thing is that you should know how to read the interpretation of the output. Now I have collected the data of height and weight. I've collected the data of height and weight. I wanted to check whether is there any relationship between height and weight. I'm going to use correlation. Can I go ahead, try doing correlation immediately? Can I do that? Can I start doing the test immediately? Or do I have to do something else? Can I go ahead, try doing the test without doing any assumptions? No. First, test the assumptions. Why should I have to test the assumption? Ma'am, can you tell me why should I have to test the assumptions of parametric or is it non-parametric? Why should I have to test? Answer is, within correlation itself, there are parametric test and non-parametric test. So to check out, do I have to use parametric test or non-parametric test? I need to do these 4 assumptions which I mentioned here. What is the first assumption for a parametric test? First assumption is both the variables should be continuous in nature. That means either they should be interval or ratio. Now look at what are the 2 variables here. Variable 1 is height and variable 1 is weight. Is it fulfilling this assumption? Ma'am, is it fulfilling the assumption? The first condition, both the variables are continuous in nature. They are not categorical in nature. Is it fulfilling the first assumption? Yes, no? Of course, yes. Look at the variable. It is continuous in nature. Second one, there has to be a linear relationship between the variable. That means if height increases, weight also should increase. Or if height decreases, weight also should decrease. How do I check it out? Easy, go to graph, legacy dialogues, okay? Legacy dialogues, and go to something like scatter plot. In scatter plot, choose simple scatter and choose, on x-axis you can choose height, on y-axis you can choose weight, and click on OK. Now you will be getting the output of scatter plot. Okay, through the scatter plot we will be able to make out whether there is a linear relationship between height and weight. Scroll down. Okay, oh my god. Okay, this is the, now you can see that how height and weight are related. Now is there a linear relationship or not? You have to click on this and a fit in total. Now you can say that of course yes, there is a positive relationship. It is approximately positive. Okay, it's not a perfect linear relationship, but it is approximately there is a linear relationship. You can see that whenever height increases, weight also increases. Okay, so now it indicates that it is approximately linear relationship is there. If you can see that what are the different ways of we finding out whether it is a positive relationship or negative relationship. If the scatters, if the scatter plots are in this fashion, we can say that it is positive relationship. If it is in this fashion, we call it as a negative relationship. If it is like this or like this, we can say that there is no relationship. Now you can see that it is approximately positively related, right? Now once we have done that, now we have to look for the second assumption. So of course now both these assumptions are fulfilled. Variables are continuous in nature. There is a linear relationship between these two. And third one, there should not be any significant outliers. And the variable should be approximately normally distributed, not perfectly, approximately normally distributed. These 2 assumptions, I can do that by using an option in SPSS, analyze, descriptive statistics, explore. Okay, and in the dependent list, choose height and weight, bring it towards the right hand side, and go to statistics and choose an option called outlier. Click on continue. Go to plots. All right, here I'm not going to explain much. Maybe you can choose this normality plots with test histogram. Okay, no need to choose any other option. Click on OK. Right, now this is a very powerful option in SPSS wherein you can get several results. Now I'm going to test two important assumptions here. One is to check out is there any outlier or not using box plot. Already we have some understanding of about box plot. So now straight away I'm going to the box plot now here. So now this is the box plot for weight. Now I have told you why to choose only height and weight, because it is continuous in nature. Okay, you can choose any options, that is not at all a problem, because if I am interested in using correlation, and for correlation I'm talking about Pearson correlation, the first condition is that the data should be continuous in nature. I can see that the height and weight data is continuous in nature. If at all, if you say that gender, it is not continuous, it is categorical in nature, right? So in that case, I may not be able to use correlation. That's the reason why I have used height and weight, and there is a logic behind it. As soon as whenever height increases, you can see that weight also increases. There is a perfect logic that is following. That's the reason why I have chosen this variable. Now you can see the weight. You can see there are no outliers. The reason being, yesterday itself we have removed all those outliers. How do you identify the outliers through box plot? There will be a star symbol, that hash symbol will be there, and you have to correct it accordingly. Already the correction is done for weight. Now let me check out, is there any outlier for height is there. Again, go to the height one. Height also, there is no outlier there. What is the another condition? That means there is no outlier. The fourth condition is that the data should be normally distributed. And I have told you, if the variable is follows the normal, the line will be in the center. This is the median line. If the line is in the center of the box, it indicates that the data is normally distributed. This is one way to find out. So that means the data of height is normally distributed. If you look at the data of weight, if you look at here also, the median line is in the center of the box. If the median line is at the bottom or at the top, it is not normally distributed. So this is visually, you can check out whether the data is normally distributed or not. You can also check it out statistically. For that purpose, you need to look out this table called test of normality. You can either go for Kolmogorov or KS test or Shapiro-Wills test. Normally, going for Shapiro-Wills test is the preferred choice, right? So in Shapiro-Wills test, you need to look out for the significant value. Now here, I'm assuming the null hypothesis as the data is normal, okay? And I am keeping the level of significance as 5%, which is 0.05. So the obtained significant value, which is nothing but the p-value, is above 0.05. Thereby, I failed to reject the null hypothesis. That means I accept the null hypothesis. What is the null hypothesis? Null hypothesis says that the data is normally distributed. That is what I have kept it. So if the p-value or the significance value is lesser than 0.05, it shows that the data is not normally distributed, because I reject the null hypothesis. Because it is above 0.05, I accept the null hypothesis telling that the data is normally distributed. So what is the conclusion? The conclusion is the data has fulfilled all the 4 assumptions of parametric test. So I can use Pearson correlation. How do I use it now? Now I can go for analyze, okay, A, correlate and bivariate, and I'm going to choose this height and weight, bring it towards the right hand side. Now you have the choice, either you can go for Pearson or Spearman. Okay, you can ignore this, normally we don't use this. Right now, I have tested the assumptions for parametric test, so I choose Pearson correlation. Okay, if it is not fulfilling any one assumptions of Pearson correlation or a parametric test, I'll be going for Spearman correlation. Right now, I'm okay with Pearson itself. Options, maybe I can go for means and standard deviation and click on OK. Right. Now, what is the output that I have got? Look at the output. This is the correlation output window that I have got. What is the correlation that I have got between height and weight? It is 0.398. Is it significant? No, it is not significant because it is above 0.05 because I have kept the assumption as 5% level of significance. So that means though there is a relationship between height and weight, it is not strong enough to say that height and weight are positively related. What is the wording that I need to use? Go to the PPT and there I have mentioned this reference. Now, if the correlation value is between 0.3 to 0.5, it is low positive correlation. So now when you wanted to interpret the result, you can say that height and weight are having low positive correlation between each other, and there is no significant relationship between height and weight at 5% level of significance. So now this is the interpretation that you can make out of this Pearson correlation. Is it clear? Anybody is having any difficulty in any of the path, please feel free to ask. Yes, Priya ma'am, Manjula, Srinivas sir, I could make out you are a little bit active. If there is any doubt on any one of these steps, please feel free to check with me. I'm ready to repeat the path or the interpretation, whatever it is. So basically, correlation is an association technique, okay? And before using correlation, I'm testing these 4 assumptions, okay? These 4 assumptions are in the PPT, checking whether it is linear relationship between both the variables, okay? Whether the variables are continuous in nature, is there any outlier is there, is it normally distributed? So to test those, I'm using this option of analyze, descriptive, explore, okay? Through these options, I'm testing these assumptions, and through the scatter plot, I'm checking is it linear relation or not. Once I've done that assumption, I'm doing the correlation. Doing correlation is very easy. Analyze, correlate, bivariate. Okay. By default, Pearson is chosen. Click on OK, you will get the output. Now, in the output, you look out for the value that is for the Pearson correlation value, which is 0.398. 0.398 is not very strong because I have mentioned it in the PPT about the interpretation, which is low positive correlation, and it is not significant also because it is above 0.0. Right. So if any doubt, yes, no, fine. Okay, so if there is no doubt, we will wind up the session now. So tomorrow again at 2 o'clock we will get into this topic called regression. Again, we will do the same assumption testing and we will go ahead with the regression. So now in today's session, we have done 2 important things. Sorry, 3 important things. One is that we have learned what is reliability, validity, and we have tested this reliability and validity for the data that we have created using SPSS, and then we did something called correlation, and we have done the assumption, and then we have done the testing, and we have learned the interpretation also for the correlation, right? Okay. So yeah, Raja sir.
Yeah, yes, sir.
Yes, sir.
Okay, sir. That's all I think, sir. No queries, I think.
Yes. Okay. Okay. Thank you once again. See you all.
Okay.
Bye.
Thank you, sir. Thank you for a useful session. Thanks a lot.
Thank you.
Thank you. you participants for your patience and cooperation throughout the session. Thank you, Nanda.